Hi there, guys. In today's video, we are going to be looking at three pieces of article, and this article I've been circulating for around over a month now, just about a month now. So the first piece is from Anthropic talking about how they built a multi-agent research system, and the second piece is from Cognition. They put a piece talking about don't build multi-agent system, and they were advocating for single agent systems. And the third piece is from me that talks about don't just build agents, whether single agents or multi-agent, actually build memory augmented AI agent. And generally, these two pieces might look contradictory at first, but honestly, both pieces are right. I'm going to talk about what both pieces are right on and why these pieces are actually saying the same thing. And I'm going to be going over mainly looking at Anthropic's learning about how they've built their multi-agent system and reference some of Cognition's talking point around why they think we shouldn't be working on multi-agent system, or why they think we shouldn't be focusing on multi-agent system and focus on more making single agent system better. But then I'll be talking about the commonalities between these two pieces. The Anthropics piece is very good. Just want to say that out loud. The key takeaway from you guys, you're gonna get some very good information on where I think the key value lies in implementing a agentic system and the key insight. And that is very simple. That is, application mode is crucial when discussing memory implementation, but extensively when you're discussing agentic systems or agentic system architecture. So the application mode. So there are three distinct application mode I see in the field today when I'm talking to customers. So deep research, that's an application mode. Assistant, that's an application mode. So assistant won't be like your typical standard chat GPT. Deep research will be when you click on that button that says deep research or whatever it says it is. Then it goes into an extensive knowledge exploration. Then the third mode is workflow mode. So this is where you don't even have like a back-to-back turn by turn interface or chat system. It's just deterministic workflow that are executed by agents. So those are the three modes, application mode I'm seeing, and they really dictate the architecture of your system or your agentic system, and even the memory engineering techniques you utilize. So this is why, to obviously get straight to the point, this is why I think both pieces are right. Depending on the application mode, they're right in what they're saying. So the application mode in Anthropic is a research system. It's deep research essentially, and multi-agent works well for it for reasons that they talk about and we'll cover as well. And Cognition focuses on really focusing on utilizing context engineering and making that work. Looking at systems or application mode where it's not deep research, right? They talk about coding assistance where you have a single task running extensively. Again, both pieces are saying the same thing. Application mode is crucial. Memory mechanisms is crucial. Context engineering is important. So we're going to look at the multi-agent piece from Anthropic in detail. So looking here, it starts off really with what they learned. And the key thing they took away was they learned a lot about system architectures. I'm going to zoom in a bit here. They learned a lot about system architectures, tool design, and prompt engineering. We'll look at what these are. But generally, they define an agent, we have to clarify this, as LLMs autonomously using tools in a loop. My definition of an agent is more extensive than that. I add one more ingredient, which is an AI agent is a computational entity that has an LLM, is following an instruction, has access to tools, but is backed by some form of augmented memory. And these two pieces of articles validate that. So I think you do need some form of augmented memory to really get into that truly reliable, believable, and capable agentic nature, ideal agentic states that you want. So they really focus on research, which is what the multi-agent system they built is focused around. The system they've built actually has an agent that plans a research process based on an input query, and it uses tools to create sub-agents and that run in parallel. And those sub-agents actually have tools themselves that also run in parallel. And this allows for very good prioritization of task and distribution of task. And it can cut down the time of maybe if we were to use a single agent for this same task. And just high level, some of what they found, the challenges they encountered were around coordination. So how do you pass information from one agent to another? Evaluation, how do you know when things are working well and what to improve? And reliability, which is looking at making sure that the outcome is the desired outcome. And you can actually rely on the information or the plan or the strategies that an agent is put together for some form of knowledge exploration, and also the path and the exploration that is being taken. So they have a couple approaches to reliability, evaluation, and coordination. One thing that they talk about is the benefit of multi-agent system. Largely, it's the fact that the nature of research is such that it is exploratory, which means that there is no defined path, and you can go into deep holes, right? Into several deep holes. And that nature, it makes it well suited for having agents that are going to explore a certain topic. So they basically say that the unpredictability of the path of exploration within research is actually good for AI agents, right? So that's one of the key benefits of a multi-agent system for deep research mode. Then they also talk about something I don't agree with. And just for context, so red highlight whenever I'm reading some of this research papers or articles, red means it's a statement I don't entirely agree with, but or maybe a statement that I think is wrong. Green is interest and insight, and yellow is just something I want to highlight and I think is important. Saying that the essence of search is compression, that's a big statement. I don't think the essence of search is compression. I think compression is important, but the essence of search is relevance, right? When you have an input query, the search or retrieval method is essentially meant to give you relevant pieces of information that are linked to the query. So I wouldn't say it's compression. In a sense, you could say it's compressing the time to find what you're looking for, I guess. But I think in this sense, the essence of search is relevant. I believe is the essence of search. I don't agree. This is not wrong per se, but I don't entirely agree with it. One thing they also talk about is the prioritization of the sub-agents, and they have their own context window. And the sub-agents, when this context window is about to overflow, they actually have a process where they summarize the token or compress the token, and that compressed token is passed back to the lead research agent. Another point is, once intelligence reaches a threshold, multi-agent systems becomes a vital way to scale performance. Sure, I agree with this statement. I think it's very important that this can be true, in the sense that the more we see the capabilities of the LLMs to reason and general overall performance and different benchmark increase, we're going to see more application of LLMs and agents to more sophisticated tasks that might involve having a coordination of different intelligent computational entities solving a specific task. It might not just be research, but a lot of tasks has some form of research in it, especially new domains, but it might be other tasks that might, I can't think of any off the top of my head. Maybe picking the next top 10 stocks for a company to invest to provide a certain percentage return for the clients over the next 10 years, right? That has some aspect of research in it, but it might be more of a task within that specific use case. I don't know, just made it up on the spot. But generally, the more intelligence increases, or when it reaches, there's a certain threshold that they feel that once it cross that threshold, the reality of multi-agent being more prominent within the application space will be realized. And if we're trying to get more out of this system, we are going to be looking to multi-agent system. So multi-agent system, according to Anthropic, is going to be very vital and important. Okay, they go into a bunch of how humans have worked in terms of how we have this form of collective intelligence that's made us more performant as a society or humankind. Then they talk about the performance of the single agent versus multi-agent scenario. They saw that with that Claude Opus 4 in a multi-agent system performs better than Claude Opus 4 as a single agent by 90%. That is a massive gap, right? Which is definitely worth exploring. The sign that there is that increase in performance, which may be an increase in accuracy or increase in objective achieved or successful outcomes from the agentic execution. 90% is a massive margin. When I read this piece, it made me actually try to implement a multi-agent system within this library that I'm working on called MemoRiz. So I have a multi-agent system here that takes some of the learnings from Anthropic and other libraries, and I try to implement them and try to see what works and try to learn myself. So 90% is massive. Single agent versus multi-agent for research, you get 90% differentiation in terms of performance. So this part talks about how it works. Taking a task, decomposing it into different tasks for the sub-agent, that each of the sub-agent execute. We'll talk more about how this works in general. But the reason why multi-agent systems actually perform better than single agent systems on deep research task is due to the fact that they spend more time on the problem. They expend more tokens on solving the problem generally. So more heads come together to solve the problem. You can think of it as that. And there is more thinking power dedicated to the problem. And then they see that this results in better performance than a single head on the problem. Head by, when I say head, agent. That's a good insight. And this is the benchmark or evaluation benchmark they're using. It's a decent insight, but there's a downside. So the downside is when you're using multi-agent system, expect your operational costs to be much higher. So 15 times more than chat systems, which could be single agents as well. So it's basically a trade-off, right? So the use case they're trying to solve, if you're able to solve this with a multi-agent system that has a huge operational cost, the business value realized, does it cover it, right? Is it viable in an investment sense? I think this is something that a lot of solution architects, product managers, even AI leaders have to think about if you're thinking about the agentic architecture of your system, right? If I go for this multi-agent system that is going to be 90% accurate than a single agent counterpart for the task of deep research specifically, that's a caveat. Is it worth expending that much money? Will I get that much return on investment? So I can't quantify that for you, but that's some maths that some solution architects are going to be doing. So there's going to be a lot of solution architects and product managers have to explain some of the benefits and trade-off and quantify that for business leaders to make the right decisions. But so they do admit that LLMs are not great at coordinating and delegating to other agents in real time. So again, the application mode matters, right? In real time, this application mode using multi-agent doesn't make sense. And they also do mention that also in coding task, they wouldn't recommend multi-agent system. And that specific quote is right here. For instance, most coding task involves fewer truly parallelizable tasks than research. And that's fair. They admit this. So application mode matters. I think I've said that 10 times now. And Cognition also mentioned this by making the example of Anthropic's Claude Code sub-agents. It's not a multi-agent system because the agents are not actually interacting with each other. It's mainly agents working in a single threaded fashion. They use the Claude example as a way that shows that parallelism doesn't work within the application mode of a coding assistant. Does application mode make sense to you guys? Is that a good way to think about things, or are you guys seeing something different? So next we go into the architecture. So the architecture is actually easy to understand. They have two depiction of the architecture. So they have this diagram, easy to understand, and they have more of a not complicated, but more involved diagram. So in this diagram, what we're able to see here is how it works, right? We'll go over it very quickly. So the use cases here, it's just the question is, what are all the companies in the United States working on AI agents in 2025? Make a list of 100. This is an objective or a task that has subtasks within it. So this is going to be this is going to be an extensive task. Even for a human to do, you're going to need a team to do this task, a team of analysts, and could take maybe several days to weeks to get this information done, and then make sure that it's accurate as well. Yeah, it could take several days at least for this to get done. So that is the user request. And then we see that there's a lead orchestrator, a lead agent that actually takes in the query. And what this agent does, according to the way Anthropic has built the system, is it is able to take a query, create a plan from what the user wants, create a plan and a strategy to attack this, and then delegate to other sub agents. Now, it delegates each of these tasks to other sub agents, and these sub agents execute the task in parallel. So you have parallelization in the sub agent execution, but also each of this sub agent has parallelization within their tool execution as well. So it makes things a bit faster. So each of these sub agent have one specific task that they're going to do, and they're able to then use tools to achieve their part of the task and then return the results back to the lead agent. They're also able to actually store information back into the memory. Sub agents can also look at the original plan created by the lead agent to ensure that they're on track or they're not deviating. And this again is done by the memory. And if you notice, Anthropic doesn't call the external memory or where they're storing the information externally as a database, because they're probably using a database. They also use a file system as well, but they don't call it a database. They call in everything memory. There's not a one mention of a database or a data store within this piece. Memory is becoming the term that encapsulates what when we talk about storing data in agentic systems. So that's why I call it agent memory, right? As apart from like agent database, it's really agent memory because there is more to it than just storing. There's retrieving. And we see that there is even more to it than just RAG. And they point this out as well. That takes us from RAG to memory. We're going to get there. So in going back to how this works is interesting, right? You have a lead agent, breaks down the task, assign tasks to a sub-agent. Sub-agent looks at the task and can look at the plan and execute the tasks. And the sub-agent can compress its current execution in the context window and pass that into the lead agent so we don't lose track of work being done. That is great. And there's one more agent, which is the citation agent, that is able to make sure that there is a reference for every key part or information that is mentioned in the synthesized piece. The lead agent gets all the information from the sub-agent, then synthesizes this result, then the citation sub-agent ensure there is a coherent citation with each key point or fact. So the one thing that Anthropic do provide is the prompt to their agents, which is very good. I'm going to try and use some of this and see how it works for my use case. So they have the lead agent prompt here, extensive, and they have the prompt for the sub agent and the citation agent. I've not looked at it too deeply, but I'll look at it when I'm trying to implement the learnings from the multi-agent system that Anthropic has given guidance on into the memories library. And I could do a video on that to show you what I'm taking away and what I'm implementing and how it's going so far. So if we go back to this piece, we know how this system works and they explain it here in more detail. And remember that point where I say we're moving from RAG to memory. Retrieval augmented generation is not all you need to make agent work. You actually need more extensive form of memory that doesn't just focus on finding the relevant information, but it adapts to new findings. So whenever you get something that comes into the context window of an agent, you actually need some form of mechanism that could take that information and store it into memory, or use that information to, in fact, update some of the existing memory that you've captured in previous execution or from other agents. That is where you go into the realm of memory engineering. So we have prompt engineering, trying to tune the instruction or change the instruction that you're giving to the LLM to make it more performant performant in some dimension. You have context engineering, which introduces some form of dynamic construction of the context window, what you're passing in. But we have memory engineering, which takes things a bit further. That goes into, not only do we try to figure out what we're putting in, but we figure out what we're taking out and what we're storing and updating with existing information and more things. There is more things around memory engineering that I'm learning every single day within the realm of agent memory as well. Let me know if you guys are, what you guys are seeing, what you guys are learning. One thing that I definitely took away is application mode matters for memory engineering, which is what I emphasize here, right? Application mode is crucial when discussing memory implementation, because these guys, these folks, these teams are talking about agentic system architecture, but they're also talking about memory as well and how memory should be implemented in these systems. Cognition point this out as well, saying if we really want to get parallelism out of our system, you might think to let the decision makers talk to each other and work things out. And the only way you can have this coordination is what Anthropic is pointing out, or this communication, by having an external system, a scratchpad, a blackboard, or some form of memory system that they can just pull information from and put information into as well, and maybe even remove information from in some cases. Cognition mentioned that humans do this as well, which is fair, true. And remember, in red, things I don't agree with, I'm going to mention something that Cognition mentioned that I don't entirely agree with, which is that it's evident that in 2025, running multiple agents in collaboration only results in fragile system. Like, that is a strong statement. I don't think that's true. I think some of the deep research tools that we're seeing from OpenAI and Gemini and Grok and Anthropic are multi-agent systems that are not fragile. They work really well. I use them in some of my use cases when I'm trying to learn a new topic or explore deeper into other topics. And this other statement where they say, at the moment, I don't see anyone putting a dedicated effort to solving this difficult cross-agent context parsing problem. I think if you look at it as cross-agent context parsing problem, I think no one is trying to solve that, particularly kept in that phrase, cross-agent context parsing. I think if you look at it as memory engineering, right? Because we spoke about this, is if you want to pass information from one agent to another, you need some form of external memory. And if you look at it as memory engineering, memory management, you're going to see a bunch of folks that have been solving this for a few years now. So we have people in the open source community solving this, and startups solving this, and even the Anthropic solving this, and OpenAI solving this. So notable people solving the problem of memory management in agentic systems, whether single or multi, are CrewAI. They have the memory equals true parameter. You have MemGPT or letter. You have MemZero. You have Zep. There's a number of folks that are emerging, teams emerging, trying to approach agent memory. So saying that there is no one putting any dedicated effort when these folks are specifically solving memory, I don't entirely agree with that statement, especially when you phrase it as cross-agent context parsing problem. It makes it very specific. But I don't know if you guys agree with me. Let me know. Yeah, do let me know if you agree with the context of application mode, memory engineering, or if you agree with things I'm saying. If you disagree, put in the comment section. But going back to the Anthropic piece, the lead researcher creates a plan and it saves the plan to memory. But also, it does a bit of compression if the context window exceeds a certain length and is able to retain the plan. The lead researcher also synthesizes the results from the other agent, then is able to then replan or re-strategize, right, if more research is needed. So the plan is stored externally. Information comes to the lead agent. The lead agent looks at the plan and say, okay, we need to, we can stop here, or maybe we need to update the plan. So there's a scenario where we have this agent that is able to update previously stored memory, so which will be the plan. So that's another form of memory engineering required as well. Should it be the only lead agent that could change the plan? Probably. Yeah, I do think so. Maybe you might have several key agents within this wider multi-agent system that can, at some level, have different access to different levels or different views of the strategic plan. That could be a good approach to another multi-agent system. Okay, so generally they found out that to make multi-agent system work, one of the key things that enabled most of the benefits they found was prompt engineering, right? And it was all about really changing the way the agent actually behaves. For example, they said, think like your agent, become one with the agent. So there's a lot of observation going on when they built this tool to know what to improve and what changes they need to make. So there's a lot of evaluation, monitoring, and observability. Agent ops is coming into play here, using tools that can really give you an insight in terms of how your agent is performing in terms of utilization of chunks or context adherence or even the relevance of the output as well is important. So evaluation, like they mentioned, is one of the key challenges that they found and they had to solve. Creating an accurate mental model of the agent is exactly what these metrics and monitoring, observability, and evaluation will help you with. They did mention they had to teach the orchestrator how to delegate. They had to take the lead agent to leadership training. We do this in corporate environments where you have managers that have to go through maybe a day or a week or maybe months of leadership training periodically, right? It's not easy to manage other people, and turns out for agents they need to be taught as well how to orchestrate and delegate. It's a problem for agents, it's a problem for humans. So they use a bunch of heuristics to guide the agent in teaching it how to delegate. They also taught the agent a bunch of ways for it to apply its resources to certain applications or apply its resources to the problem appropriately. Here, the problem was they found out when they gave it some queries, it spun off maybe 50 agents, and that was not really a behavior that they expected. So they had to give it some heuristic on how, or to guide its judgment on how much resources to allocate to some specific task. And again, this is not secret.
They call it sub-agent count guidelines, which is interesting, right? They tell it, there's a prompt head that tells it how many sub-agents to create. If you have create one agent to collaborate with you, what is the tax deadline for this year? Or research about it, you only need one sub-agent. So you need 5 to 10 agents for high complexity. So there's a bit of like a spectrum of the complexity of the queries that come in, like 14,500 CEOs, birthplaces, and age, and it gives it some instruction on how many agents, and it gives it a maximum number of agents it can use. So 20, which is fair enough. And that's in the prompt. There is a lot of learnings and there's a lot of interesting things that we can extract from this as well. And then tool design and selection are critical. Anyone that's actually built tools or implemented tools for agents will find that the naming of the function in the tool description really helps with the selection of the tools as well. There are ways you can use memory, toolbox memory, to really scale and scale the tool selection and make the tool selection more efficient. I might talk about that later, but for those of you who are eager, you can look at the library memories and you can look at toolbox. This is a form of toolbox memory, and I use it as a way to kind of help with the tool selection within AI agents. So let agents improve themselves is another key insight that was extracted. I'm going to do a video where I take out all of the extracted knowledge from this and implement it and show you more of this in detail. One thing I want to skip to is I want to go into the appendix. But before I do that, this is the prioritization point in green, which is they have two kinds of prioritization, which is first, the lead agent takes a task, breaks it down, assign the task to 3 to 5 agents or maximum 20 from the prompt you've seen. Those agents execute in each of their own threads, so it's parallel. Within the sub agents, they have 3+ tools that they can use in parallel, and this cuts research time by 90%, which is huge time saving, but obviously it's going to eat up a lot of compute as well, which would then increase some of the operational cost of your system. Okay, the next section goes into a lot of the evaluation of agents. Going very quickly into some of the key memory things I'm taking away for this, and going into why I'm saying AI agents need augmented memory is quite simple. If you go into the appendix, they talk about some of the key takeaways and insights.
And they really touch on the fact that production agent often engage in conversations spanning hundreds of turns. And there needs to be not just prompt engineering, right? There needs to be context management strategy. So context engineering. So again, they're both saying the same thing, context management or context engineering. I prefer context management better as a term, but then they go into the realm of intelligent compression. Compression is important. Compression has always been important. I did a course over at Deep Learning AI where we focused on prompt compression and query optimization. This was over a year ago. And I talk about the LLM Lingua library from Microsoft, researchers at Microsoft. This library gives you prompt compression techniques, and it makes it easier for you to implement prompt compression or prompt compaction. Some people call it that. They really talk about the whole compression technique, and they talk about memory mechanism being another key ingredient into making multi-agent system work in production. And this essentially, all of this, you can wrap it in the subject of agent memory, and really this specialization here would be memory engineering. So we went from prompt engineering to context engineering to memory engineering. I think we're realizing the complexity of making AI agents more reliable, believable, and capable. They mentioned actually taking all of the patterns they implement. So when an agent summarizes completed work, they store that in memory. When an agent makes a plan, they store that in memory. And they also can retrieve context from plan from their memory, and rather than losing previous work. So this is, again, how they're using memory as well. And lastly, we see here sub-agents call tools to store their work in external systems, then pass lightweight reference to the coordinator. So there's a form of workflow memory that each agent is able to store externally, and then the form of ID of that workflow memory is passed back to the lead agent, right? So I have another memory type here, workflow memory, that I experiment with over here. You can check it out. I'm going to go over each memory type in detail individually in a couple video. But here we can see Anthropic are using workflow memory. They probably have toolbox memory to allow for tool selection. They have shared memory as well, and they have the storage of planned memory. They probably have a bit of conversational memory for each of the agents that they have. But memory is becoming important, and it is becoming more of a topic that people are trying to focus on. And this statement is ingrained because I agree with it, strongly agree with it, that the observation from cognition from Anthropic are just what we might need to consider if we want to actually standardize principles for building agents. So I do think there does need to be a way of building memory in a agentic system that follows some guiding principles. I think we're going to see that coming, if not this year, we'll probably see it early next year as more people experiment with this space. And that's why I say, look, AI agents need augmented memory. RAG is not all you need. Anthropic mentioned that, and I mentioned that reliable, believable, and truly capable agents depend on robust, persistent memory system that can store, retrieve, and update knowledge over long, complex workflows or interactions or executions or research. I'm seeing definitely memory engineering becoming more important, or memory management, the same way we have context engineering, or Anthropic call it context management. And it's going to be a very important and key specialization within AI engineering itself. That's what I think. So don't just build agents, build memory AI agents. I'm gonna end the video there. In the future video, might not be the next video, I'm gonna look at all the learnings from Anthropic and show you how I'm utilizing that in Memoriz. First, I might do a video introducing the Memoriz library and how to use it. It's going a bit of stars and some forks. I might do a video, just give a very good overview on how to use it within your framework or within just using Memoriz itself. Then I'll go into the single agent architecture. Then I'll go into the multi-agent architecture of it. Then I'll do a video on each of the memory types as well. I think that's the order I'm going to be doing things. And let me know if you like videos like this. I find these pieces of articles very interesting. I read them extensively several times and I make highlights. Same with the research papers. So let me know if you like videos like this or insight breakdowns like this, if you want to see more things from me like this as well. So thank you for your time, guys. I'll see you in the next video.